Hello everyone, my name is Varsha. In this video, I will be covering a topic related to analysis and design of algorithms subject, that is selection sort, which is one of the topics under brute force approaches. The topics I will be covering in this video: introduction to selection sort, the algorithm and the working procedure of it, and the last is the complexity analysis. A selection sort is a simple and efficient sorting algorithm that works by repeatedly selecting the smallest or largest element from the unsorted portion of the list and moving it to the sorted portion of the list. Similarly, as with the bubble sort, after the first pass, the biggest item is in the right place. After the second pass, the following biggest is set up. This procedure proceeds and requires n-1 goes to sort n item, since the last item must be set up after the n-1 pass. Algorithm. The selection sort algorithm requires an input, that is an array of 0 to n-1 orderable elements, and the output of the algorithm will be a sorted array in non-decreasing order. For I is equals to 0 to n minus 2 do minimum is equals to I. For j is equals to I plus 1 to n minus 1 do. If a of j is less than a of minimum, minimum is equals to j. Swap a of I and a of minimum. The algorithm explains that there are two for loops, one for finding the minimum element and one for the element that is to be compared with the minimum element. So j will be considered as the position for the element which is to be compared with the minimum element, and I will be considered as the position of the minimum element. And now if the adjacent element is lesser than the minimum element, then the minimum element will be changed. It will be replaced with the j element. And now since the minimum element is changed, a of I and a of minimum element will be swapped. Coming to the working procedure of this selection sort. In the selection sort, first of all, we set the initial element as the minimum. Now we will compare the minimum with the second element. As I said, the second element is j and minimum element is I. If the second element turns out to be smaller than the minimum, we will swap them, followed by assigning to a minimum to the third element. Else, if the second element is greater than the minimum, which is our first element, then we will do nothing and move on to the third element and then compare it with the minimum. After the completion of each iteration, we will notice that our minimum has reached the start of the unsorted list. For each iteration, we will start the indexing from the first element of the unsorted list. We will repeat the steps, that is from 1 to 4, until the list gets sorted or all the elements gets correctly positioned. We will say this with an example. I have considered here an array A with 5 elements, 7, 4, 3, 6, 5. Now for the first iteration, the first step of the algorithm is to consider the first element as the minimum element. So the first element in my array is 7. I am considering the minimum element as 7. So after considering the minimum element, I have to compare it with the adjacent element, that is jth element. So since here 4 is the jth element and it is lesser than the 7, we are changing the minimum element from 7 to 4. I am setting the minimum element as 4 now. Again in the next step, 4 comparing it with the next element 3. Again 3 is a lesser element than 4. So I am setting minimum is equals to 3. Again 3 is compared with 6. So 6 is larger than 3. So no swapping. Since 5 is larger than the third element, we are not swapping. Now At the end of this iteration, we found that 3 is the minimum element in the given array set. Now we are swapping the third element, the 3 element, to the starting position. Why? Because we have considered the first element to be the minimum element. So now 3 will be swapped with 7. Since 3 is the smallest element, so we will swap A0 and A2. 3 and 7 are swapped. So now for the first iteration, this is the result. 3, 4, 7, 6, 5. Till now it is not sorted. Now for the second iteration, we are considering the next element, that is 4 as that is I plus 1. For the second iteration, we are considering 4 as the minimum element. Again, the same process, we will compare the 4 with all the elements. If we find any lesser element than 4, we are changing the minimum element. 4 is compared with 7. 7 is greater, we are not swapping. In the same way, 6 is greater than 4. We are not swapping. It goes with the same process for 4 and 5 too. So since 4 is compared with all the elements, we are not changing the fourth position. Since minimum is 4, no swapping with the other elements. Now for the third iteration, again we are comparing 7 with 6. 6 is smaller than 7, so we are setting minimum as 6. Again 6 is compared with 5. 5 is lesser, so minimum is set as 5. The element 5 is replaced with the 7 element here. Because we considered in the first step at the starting of the iteration, we considered 7 as the minimum element. So that should be swapped with the minimum element. So now the array looks like 3, 4, 5, 6 and 7. Since 5 is the smallest element among the leftover unsorted elements, so we will swap 7 and 5. For the fourth iteration, 6 is taken as minimum. We are comparing it with 7. Since 6 is smaller, we are not swapping and we will persist the minimum value as 6. Since the minimum is already placed, that is 6 is already placed in the correct position, we will not be swapping it again. So this is the final sorted array. So this is how we will implement the selection sort algorithm for a given set of array. Coming to the complexity analysis, it refers to the technique that characterizes the time taken by an algorithm with respect to the input size. So as the input size of an array increases, the time complexity of an algorithm will also increase. For the selection sort algorithm, the time complexity is big O of n square in all the 3 cases. The time complexity of the selection sort remains constant regardless of the input array's initial order. At each step, the algorithm identifies the minimum element and places it in its correct position. However, the minimum element cannot be determined until the entire array is traversed. This was about the selection sort. Thank you.